All right, everyone, welcome to week 33. And we're going to be doing things, as you might have noticed, a little bit differently. Some of you wanted to be able to do things ahead of time, so I'm posting all the notes right now. This lesson here is recommended for Tuesday, but if you're doing it another day, that's just fine. That's when it's going to be recommended, and you'll see it in the check-in starting on Wednesday then. So take this opportunity, if you haven't already, to print the guided notes or get yourself ready, copy down the problems. Make sure that you're pausing and rewinding this video as needed. You have the ability to turn on subtitles, closed captioning down here for most of you at the bottom of your screen, if that's going to be helpful for you. So let's get started. Today we're going to be talking about solving systems of equations with more than two variables. So last week we saw a lot of x's and y's. So now we're going to throw in another set. The homework here, again, this week we're still not going to worry about the presentation. So just 15 through 31 odd, like it says in the assignment on Google Classroom. So what you might recall with systems of equations is that if we have three variables like this, we need three equations. If we had 17 variables, we'd need 17 equations, and so on. So one thing I hope you notice in the question here in this set is that we thankfully have a bunch of like terms that are already matched up. So you've got all these 2y terms. And so we're going to use a combination of several methods, but we're going to use elimination here because they all match up. They're ready to be eliminated. So what we're going to do is look at them as separate entities. So pretending that we don't even see the other one to start with. So we're just going to ignore this one for a second. And looking at these first two, we can combine them and eliminate the y terms, and we end up with 2x plus 2z equals 12. Now, we can also do the same thing. I'm going to erase the marks I made. I can do the same thing with the bottom two, ignore this one for the time being, and these two equations I can combine by subtracting, because they're both positive in this case. So if I subtract these two equations, they combine, so the middle and the last one, into negative x. And remember, when we subtract one term, we're subtracting all of them, so this becomes positive. Negative x, the y's cancel out, plus 4z is equal to 10. And the reason that we think of them both separately like this is now we have a nice system of equations like we would have seen in the previous lesson with just two variables, and we can use whatever method we like. I'm going to use elimination. I could choose whichever variable I want to eliminate. They're both pretty simple. I'm going to eliminate the x variable here, and so this is 2x, this is negative 1x. So I'm going to multiply this second equation by 2, and then I'm going to rewrite my system down in all this space here just because there's more space. So now we have 2x plus 2z equals 12, that first equation, and my new multiplied one, negative 2x plus 8z equals 20. And now when I combine them, the x terms cancel out, and I'm left with 10z is equal to 32. So my z term is 3.2. As you add variables, you start to get slightly more complicated answers. That's just fine. You're still going to have plenty of nice integers. Things work out, as we've talked about before in class. Once we have a z, we can go and just use one of these to find our x value. So in this case, 2x plus 2z, which is 3.2, equals 12. Got a little arithmetic there. We end up with 2x plus 6.4 equals 12. keep solving, you should get x is equal to 2.8. So I cleared up our space a little bit. We have the two answers we found so far. And you'll notice here we still have one variable missing. But we have a bunch of these equations that'll help us get there. So I'm just going to take this first one here that says that x minus 2y plus 3z equals -1. Well, we know x now is 2.8 minus 2y plus 3z, which is 3.2, is equal to -1. Then we can just be subtracting these terms over, divide by the -2, and you should get y is equal to 6.7, which I'm going to actually just write over here. Now, I'm fine with when we get back into a room together, if we get that opportunity, you can rewrite it like this. Your book will still be using the ordered pair system, but in this case it's not pairs since there's 3 of them. So it's an ordered triplet. The x term comes first, 2.8, then y, and then z, just in a nice order like this here. So you'll have plenty of them that just work out nicely like this. You're also going to have some that are going to be no solution, and you'll have some that are going to be infinite solutions. So let's look at a few of those. So here in this example, I'm still going to use something similar to elimination, but we don't have any of the terms that perfectly line up. However, here we will notice that this is 4y, and then we've got 2 and 2. So it seems to me to be easiest to just multiply both of these by 2. Alright, so here we've got our new equations. The first two being multiplied by 2, and this third one staying as is. So similarly to what I've been doing before, I'm just going to be thinking about them in sets of 2. So the first 2, I can subtract everything, and that's going to get rid of the 4y. And so then we're left with -2x, and the two negatives there become positive, so that's -2z equals, whoop, forgot one negative. Good thing I caught that. -10. And then we think about the second 2, and we'll leave those negatives there so the y's still cancel, and we get -x minus z equals -7. Here we can use elimination. I'm going to multiply the second one by 2, and we end up with -2x minus 2z, not another x, 2z equals -14. And I would hope that you would notice that even though these sides are the same, these numbers are totally different. And so then this is one of those cases that you don't even have to keep going. You can just say, oh, this is a no solutions. You could say DNE. You could say no solution, singular. Any of these would be just fine. All right, here, as forewarned, we've got our infinite solutions one. There's definitely some struggle with this. This is sort of the new idea from last week. So I'm going to work through it a little bit so that we realize there's no solutions, and then talk about how to write it. So again, in this case, I'm going to cancel out the a terms because they all match. I'm going to make this middle one a negative so that everything cancels out. And I'm left with 2 sets of equations. All right, and you'll notice here that we that all the terms cancel out, and we get 0 is equal to 0, which isn't infinite solutions, but as we've seen in the previous chapters, we're still talking about something that is just a line, and so we want to have that in its mx plus b form so that we can be more precise when we say infinite solutions. So first I'm going to take this equation that we have arrived at here. So we know that 3b minus 6c equals 6, and if we're thinking about a slope-intercept form, even though we're looking at different variables, that's just fine. But we can solve for b, and we can then say that 3b is equal to 6c plus 6, and then b is equal to 2c plus 2. So when we think about our ordered pair, we're going to have an A, a B, and a C. And now we know that B can be written as 2c plus 2. C can just stay as C, so then our goal is to rewrite A in terms of C so that we have one variable throughout. So to that goal of getting A by itself in terms of C, the first thing I'm going to do, this is just this initial equation up here. First thing I'm going to do is get rid of the B, substituting in 2c plus 2. And then we're going to solve for A over here on this side. And I know I'm jumping some algebra steps, so please ask me questions in here or in the video chat if you're stuck. But now we have A by itself, and we can plug that in here, and we have negative 3c. Now I'm fine with it like this. Your textbook is always going to use t as the variable, so you might see negative 3t, 2t plus 2, and t as your final answer in the back of the book. So make sure, especially if you're working ahead, that you're checking in for that daily assignment on Google Classroom, checking in for your homework schedule and any questions that you might have posted up there. And then let me know if you're stuck on anything from these problems. So smash that like and subscribe button as always, and I will look forward to talking to you later.